Rules for Exponents, a Memory Trick by Patricia Wallace Gomez. This is as originally published by NCTM, that's the National Council of Teachers of Mathematics, in their October 2012 issue of the Mathematics Teacher. Okay, so the rules for exponents, we're going to do a review first, and then I'll show you an easy way to remember all the rules, not to get them mixed up. And it's easy because it connects to something you already know. Okay. So to start with, we'll take an example, x squared times x to the third power. And we already did this, but I know by the end of the chapter, sometimes you get the rules mixed up. Is it x? Do you do 2 plus 3, x to the fifth? Or do you do 2 times 3, x to the sixth? Okay, some of you probably already know the right answer, but some of you are still not exactly sure. Okay, so a way to figure it out is to go back and break it down. Take x squared. X squared means x times x. And then take x to the third. That means x times x times x. And by the associative property for multiplication, it says you can regroup. As long as all the numbers are multiplied, you can regroup them. And if we group them all together in one large group, you can see that it's x to the fifth. So the correct answer was x to the fifth. So x squared times x, times x to the third equals x to the fifth. Okay, and one example does not prove that a rule is always true, but in this case, it's a good example and it actually does demonstrate the way the problems do work. Okay. Yeah. All right, so this shows us that the rule is that multiplying to multiply two numbers with the same base, and the base is the x number, the 2 is the exponent. So to multiply two numbers with the same base, actually we could multiply more than 2, so I'm going to leave out 2, just to multiply numbers with the same base. They all have a base x. Okay, so the rule is to multiply numbers with the same base. You keep that same base. Notice the x was the same and it stayed x. And then you add only the exponents. The 2 plus 3 gives 5. All right, another example would be if we were dividing. X to the seventh divided by x to the fourth. Okay, and again, you may remember what this should be as the answer, but I'm going to show the idea behind it, and then we'll get the rule from looking at this example. X to the seventh means x is multiplied as a factor 7 times. 1, 2, 3, 4, 5, 6, 7 times. And x to the fourth would be multiplied 4 times. All right, and then as long as the numbers are all multiplied, there's no addition or subtraction involved, you can cancel. And it's the idea of dividing. X goes into x once. Okay, x goes into x once. And I'm putting a 1 in both the numerator and the denominator. Okay, and that way this simplifies down to just 1 times 1 times 1 times 1 times x times x times x, and that's 1x to the third over 1, which is just x to the third. So our beginning problem was x to the seventh over x to the fourth dividing, and our answer was x to the third. And that shows us that again, when the bases are the same, they're both x, the x remains there, and all you do is subtract the exponents. 7 minus 4 leaves 3. Because the idea of canceling pretty much shows you you're taking away some of the x's, and taking away would be to subtract. Okay, so in this case it gives us an idea of the rule again, that we subtract the exponents. When we're dividing numbers with the same base, the base still stays there and we subtract the exponents. And when you compare back, it makes sense because they are inverse ideas. When it's multiplying, you add the exponents. So when it's dividing, the opposite of multiplying, the opposite of adding, you subtract the exponents. That kind of makes sense. Okay. All right, another problem to consider would be x squared raised to the third power. So we have an exponent inside the parentheses, and we're raising it to a higher exponent. And again, I'm going to go back to the basic idea. This means x, the whole parentheses actually multiplied, 3 times. The exponent 3 goes to the parentheses, means you have 3 factors of the parentheses, and each one of those has an x squared in it. Okay. So if we break that down, that's x times x multiplied by x times x, and again multiplied by x times x. Once more, we can do the associative property for multiplication, which says you, as long as they're all multiplied, you can group them all together in one big group. And you see pretty obviously that you have x to the 6th power. So x squared to the 3rd power, a higher exponent, and it equals x to the 6th. Okay, so x squared is a monomial. When we raise that monomial to an exponent to the 3rd power, we keep the base, we keep the x, and multiply the exponents. 2 times 3 to get 6. So here we multiply the exponents. So one time you add, one time you subtract, one time you multiply. Okay, so we should all be familiar with the word PEMDAS. It's for the order of operations, but I always write it vertically. First you do what's inside parentheses, second step is you do exponents, third step multiply and divide left to right, and the last step add and subtract left to right. And some people remember the phrase, please excuse my dear Aunt Sally. Okay, so either way you remember it, this is the order. Here's the trick. When multiplying numbers with the same base, the exponents add. Here's multiplication, and adding is directly below it. You look down one level on the PEMDAS chart. When dividing, the exponents subtract. Here's dividing. Look down one level, the exponents subtract. Okay. To raise a monomial to a higher exponent, you multiply. Here's exponent, and you multiply. I should have boxed in exponent. To raise to an exponent, you multiply. Okay, so what about add and subtract? Okay, this is a real easy problem. Everybody knows the answer. It's 5x. We can look at an easy example again. It's nice to go back at this point to say this came from distributive property. X times 2 would be the 2x, x times 3 would be the 3x. And that's where we get the 5 from. So that's the 5x. Okay, so if we had exponents involved, something like x to the 4th, 2x to the 4th plus 3x to the 4th, we could do the same distributive property. X to the 4th times 2 would give me the first term, 2x to the 4th, and x to the 4th times 3 would give me the second one. And then the 2 plus 3 adds, and it's 5x to the 4th. So we see nothing happens to the exponent. It stays the same. Okay, looking again at the PEMDAS chart, underneath adding or subtracting, there is nothing, which tells you you do nothing to the exponents. They stay the same. They have to be the same, and they stay the same.